Hello students, welcome back. This is the third lecture of the topic PCB design. Today I am going to discuss about the PCB components. So different type of electronics component we mounted on top and to the PCB. So uh, Going to the first discuss about the component. So this is a most of the common component resistor. Resistor limits the flow of the electric current in a circuit. It is measured in the unit ohm, and it is the one of the most fundamental component of any PCB board. So the functions of the resistor controls the current and voltage levels. As per the color code, you can able to find the value of the resistor. Common uses LED current limiting, pull up, pull down networks. Next is the capacitor. Capacitor stores electrical energy in an electric field and releases it when needed. So it is a measurement of how much energy, charge is stored into the particular capacitor. So this is called capacitance. It is measured in the unit farads and is essential for filtering and timing circuits. So function, store and release the charges, filters noise. So the different types of capacitors are available: ceramic, electrolytic, and polarity. Some are polarized and some are not polarized also. So common use, decoupling, smoothing the circuit. Suppose if you are using the rectifier circuit, if any ripple factors are there in the rectifier circuit, after the rectification also we can smooth this graph, or we can reduce the ripple factor through the capacitor. So this is called as a filter. Capacitor uses a filter also. so uh, these are the types or capacitor: ceramic versus electrolytic. So suppose the dielectric property, the ceramic material, uh, ceramic means the you need to use the ceramic materials. Electrolytic means it must be oxide layer or electrolyte. Polarity, as per the polarity, ceramic is non-polarized, electrolyte is polarized. Frequency response, excellent in radio frequency and gigahertz frequency, ceramic, but electrolyte, it is poor frequency response in the low frequency only. So it is poor. Frequency response is poor in high frequency, and it is used only the most of the time low frequency region. Size for ceramic is very small, electrolytic is larger. Cost, ceramic is low and electrolytic is low to medium. Stability, high, ceramic is high. Stability, electrolytic, it is a liquid form, so you can tell it is a moderate. It may be uh, uh, degrades over time. A leakage current, ceramic is near to zero, electrolytic is measurable. Lifespan, ceramic is very long because the degradation is low, and electrolytic is limited because very easily electrolyte maybe dries out. Yes, sir. That means internal resistance, ceramic is very low, electrolyte is higher. The typical use of ceramics, it is decoupling, RF, filtering, timing. And electrolytic, power supply smoothing, audio, and bulk storage. So next to the passive component, it is called inductor. It is very important component of the electronic circuit, and it is widely used in PCB board. An inductor stores energy in a magnetic field. When current flows through it, measured in Henry, actually it is the unit of the inductance. It resists changes in current and is widely used in power supply circuit. That means simple, if the very simple word, if I want to tell, inductor is nothing but it will it will uh, store the energy in a magnetic form. So the function opposes change in current, stores magnetic energy. That is simple thing. It will store the energy in a magnetic form. So there are types: is air core inductor is there, and iron core inductor is also available. Symbol, we all know that this is a very normal thing, like a coiled wire. And common uses is filter, transformers, DC to DC converter. Widely we are using in the transformer. So step up, step down, any type of transformer mainly used using the inductor. So L inductor, the symbol, suppose the equation L equal to minus d phi by dt. This phi means nothing but a number of flux cut. Uh, it is now, or number of changes of flux in particular time, dt. T means time. And why it is minus? Because it is always opposite source. For this reason, it is called, it is minus is there in this equation. So L equal to minus d phi by dt. So it is the formula of inductor. So inductor also widely used in the PCB board. Next is the diode. So in the modern electronics, we can't think about the diode. So diode allows current to flow in only one direction, acting as an electronic one-way valve. It is a fundamental building block in rectification and signal protection. So that means if you want to design the rectifier, that means suppose AC to DC, we can able to use this diode. So it is a one way. When it is forward bias, so this diode will be on, and in that time the current will flow. When it is the reverse bias, the diode will be off. The current will not able to flow. So you can tell it is treated as a one-way valve. That means one type of switch, you can tell. One-way switch. When I give the forward bias, in that time this current will flow. When I am diode will be a reverse bias, in that time current will not flow. So this is the thing of the diode. Okay. So this is a so this is a, you can see, this is a anode part, this is the cathode part of the diode. So if I give uh, this forward bias, so diode will be on. So if I give if I give uh, suppose reverse bias, in that time diode will be off. Okay, so actually diode is nothing but a one, this portion is a anode portion and this portion is a cathode portion. Actually diode is nothing but a one simple PN junction. So P means more of the positive charge, N means more of the negative charge. So when the two materials come and touch with it, so due to the diffusion, some of the positive charge will come into inside. Same thing. Some of the negative charge come into the positive side. So one PN junction will create. So if I give the PN junction will create, and this region is called depletion region. So if I give the forward bias, what will happen? So this is a positive charge. It will be repel if you want to go here, because here is a positive, here is a negative. So it will cross the junction. Same thing for N region also. Electrons will repel in this field and it will cross the junction. So electron and holes will cross the junction and and the current will flow. So in spite of give this, if we change this bias, in that time this depletion region will be increased, and due to this, no electron or no hole will can able to cross the junction, and due to this, diode will be not conduct. Okay, so this is diode. Okay, next is the transistor. In the transistor, it is a three-terminal device. So one is emitter, and there is base, and there is collector. So diode, we not able to control. It is not a total controllable. It is semi-control. That means through the bias, I can able to control the diode. For transistor, we can able to control the transistor, not only bias, we can able to control through this base. So emitter emits the electron or holes. Base will control the direction. Collector will collect. So we can control the flow of electron or holes through this base. So for this reason, it is called three-terminal device. Diode is a two-terminal device. The diode only we can able to control in one way. But transistor we can able to control through the emitter or collector bias, and also through the base. That means base also able to through the base voltage we can able to control the flow of the electron and holes. So it what the function? This is also a very important component. Amplification, electronic switch, BJT, types of the transistor we are using BJT, bipolar junction transistor, MOSFET we can using, JFET we are using. So also this type, this is also very much common use of uh, common components we can able to use in the PCB board. Okay. So different type of now IC is available, and IC's microchip also be we can able to use into the PCB. So there are two types of ICs are there. Actually, in broader way, one is digital IC, one is analog IC. Digital IC means microcontrollers. Suppose 8086 microcontroller, 8085 microcontrollers. Sorry, 8086 microprocessor, 8085 microprocessor, 8051 microcontroller. We can able to use into the PCB board. All we are using the smartphones, smartwatches, our laptops, all have this microcontrollers or microprocessors into inside this smart devices. So it is very much important. So so different type of analog ICs also we can able to use. Suppose op-amps, comparators, sensors, and mixed signals devices, ADC, DAC, communication IC we can able to use into this PCB board. Different type of oscillators are used also be used into this board. Fisher oscillator uses the mechanical resonance of a vibration quartz crystal to generate a precise electrical frequency. It provides the clock signal that synchronize digital circuits, and the function is uh, uh, generate the different type of signals, uh, and stable accurate frequency we can able to generate through this oscillators. So common frequencies are 4 megahertz, 8 megahertz, 16 megahertz, but as per you need, you can able to use this uh, type of oscillators. So it is using for timings. So if you want to measure the performance of any device, we need timers. For this reason, we need timings. So through these signals, we can able to measure the performance of a particular device. So it is a crystal oscillator. So voltage regulator, we can use into this PCB board. Voltage regulator maintain a constant output voltage regardless of changes in load current or input voltage. It ensures stable power delivery to sensitive components, provides stable regulated output voltage. So it is also be one type of component which can able to use into the PCB board. Or different type of connectors, headers, and PCB substrate we are using. So connector headers means if you want to create one jack and connection to the PCB board, this thing also be we can use. So USB port, what we are using in the laptops very frequently in our computers, USB port, a very important thing. So these ports also be we can able to adjust into this or mounted into the PCB. So PCB substrate is FR4 fiberglass. All of you knew that. So this is the thing. This is the small discussion about the different type of components what we use in the PCB. Again, I am giving the thanks to my student uh, who helps me to prepare this PCB and this video also. So thanks students for this help. In my next class, I will discuss about the manufacturing of the PCB and how we mount the PCB into the PCB, how I mount this type of component into the PCB board. Thanks, everyone.